Hello again, students, and welcome to the video on domain and range. So imagine that you could list every single ordered pair on the graph of a function. So you have some kind of awesome graph. And let's pretend you wanted to list every single point on this graph. Now you couldn't do it. It would take you literally forever. But let's just pretend. Let's pretend you want to do that. So when I say domain, what that means is I just want you to tell me what all the x values would be without having to list them all, hopefully. And the range will tell you what the y values would be. So just remember domain and range. Okay, so let's just dive into an example and use that to kind of review these concepts. So give the domain and range of the graph f of x. So remember from the last video, we're naming the function f, x is the input, and this is the rule. So we could call this y equals x plus 1 squared minus 3. This is just giving it a specific name, that's all. We're going to look at the graph of this function first. So I've got it typed into Desmos. I've got my function typed in here. And I want to know what the x values would be. So if you can just kind of imagine, this is a nice thing about Desmos. If you click on the line, either with your mouse or your finger, it will show you the coordinate that you're on. And it's got some points there for you already, the intercepts and then the vertex, in the case of a quadratic. So I want to look at the first number. Those are my x values. That represents my domain. What values could I have in that spot for x? So for a quadratic, you could imagine that if I just kept going forever and ever and ever, in fact, let me zoom out. So I've zoomed out some, and now my x values are not much bigger, 6.68. But they would keep going and going and going eventually. And as you can see, this one is really steep, so the x values don't go very quickly, but there's already 16.9. So if I just kept moving along this graph, my x values would keep getting bigger, or if I kept moving this way along the graph, my x values would keep getting smaller. So I could have any number. If you can imagine, I can just have any number at all for my x value. Now I'm going to write that. So what numbers will eventually be used as x coordinates? I mean, any of them can be. Any of them. That's an F. Any of them. Any of them at all. Every number you know about. In fact, all real numbers is the mathematical way to say that. And you saw this on your parent function foldable as well, but for several of the functions. So the domain, if it's any number at all, you just write all real numbers. That's your domain. And all real numbers has a symbol, which again you saw in your parent function foldable. It's an R. It's a bold R, but when we're writing, we can't do a bold letter. Like these are bold letters. We can't do that when we're writing. So we just do like an R, a capital R with two sticks. That's all real numbers. Okay, so if you see that, this just means all real numbers. And so let's look at the range. So follow the graph from bottom to top. All right, so bottom. Here's the bottom of my graph. Now, I don't care about the first number anymore. I'm looking at the second number, the y value. So right now my y value is -3. If I try to go below that, does this graph exist? Does this parabola exist anymore below -3? And you could see from when we zoomed out before, and just remember the shape of a parabola is a U. No, it doesn't go below that. It just keeps going up. So my y values can go from -3 at the bottom. Let me zoom out. And if I try to go all the way to the top of the graph, when's it going to end? Is it ever going to end? It is not. It's going to keep going up forever. So in kind of everyday English, we could say -3 and up. And mathematically, we would say our y values are greater than or equal to -3. So I've got a list here of some important symbols that you will need for domain and range. less than, greater than, less than or equal to, greater than or equal to. You should be familiar with those from previous classes. Here's your set of all real numbers. So that's that symbol. And this is one that confuses students. It's just shorthand for is an element of the set. So like if I wanted to say that x is a real number, I would write x is an element of, it's just like x is a member of this family or something like that. Kind of means the same thing. So x is an element of the real numbers. That's all that means. That looks really funny. There we go. Let's try some others, and we're going to practice using these symbols. So write each domain and range below using words and inequality notation. That's what this is, and that's inequality notation. So let's check out example 1. I'm going to pull it up on the graph, and then we'll look at domain and range. Here's my function pulled up on Desmos, and I want to know what the domain and range are. So kind of like before, it's another quadratic, so you know what? It's going to look a lot like the example we did above. So what x values can I have? Well, I could follow this graph as far to the left as I want, and the x values would keep getting smaller. To the right, I could keep following, here we go, could keep following them to the right, and they'd keep getting smaller, or rather bigger. So I could put any x value I want in that ordered pair, and it would be somewhere on the graph. So my domain is all real numbers because I can have any real number at all as an x value. Domain in words, I can have any number as my x. And then domain in inequality notation, usually you might see just the all real number symbol, or more correctly, you'll see x is an element of the real numbers, like that. And then let's check out the range. Range is bottom to top. So the bottom of my graph, I want to look at the y value, which is -3. So if I follow the red line, my y value is never going to be smaller than -3 because it doesn't exist below that. The line isn't there. So my range is going to be -3 to, and how high do you think I can go? How big can my y values be? So bottom to top. Does this graph have a top or does it keep going? That's right, it keeps going. This graph goes on forever, it keeps going up. So my range is basically -3 and up, actually exactly the same as it was before. So in inequality notation, I could write -3 is less than or equal to y is less than infinity. Or I could just shorten that to exactly this, so it's the same thing. You just kind of flip it around. Y is greater than or equal to -3. Either way is correct. Okay, let's try the next one. So this is a linear function, and as you know from your foldable, your domain and range are going to be the same on here. So any number, my domain is really any number at all, which we would say x is an element of the real numbers. And the range, same thing. I can have any number as my y value. So I would say y is an element of the real numbers. Example 3. Example 3 and 4, I've got graphs here for you already, so we don't have to go over to Desmos to type anything. And I want to point out, in case it's not clear, this is an open circle. Right here at 4, at the point 40, it's an open circle. That means the line doesn't actually touch that point. So, domain in words. So I just want to go, remember domain is left to right. So my leftmost x value, my leftmost x value is -4. So my domain goes from -4 to, and then go all the way to the right. So I don't care about the up and down at all right now. I just want to go all the way to the right, which is 4. So -4 to 4. But since I'm not including +4 when I write it in inequality notation, I need some different symbols. So my leftmost is -4. So -4 is less than or equal to x. And then we don't want this less than or equal to 4. We don't want just less than 4. So I actually want to, we'll come back to this in just a second, but I want to go down here. ignore this right now. So when you have these two symbols without the equal to sign, so either less than or greater than, that's when on a graph you would see an open circle. So like you have your line, blah, 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 and there's an open circle. Or if you see, like you have your line and an arrow going to infinity, that's when you would use these symbols. Otherwise, you would, I gotta keep ignoring that, we'll get there in a second. Otherwise, you would use less than or equal to, greater than or equal to, when you have a closed dot, so there's your line, you have a closed dot, or if you just have a solid line with no dots at all. So that's the difference there. You probably, hopefully remember that from Algebra 1 a little bit. Back to example 3, let's look at the range. So range in words. First, let's go to the bottom of the graph. Where's the bottom of the graph? Oh, -4. And where's the top of the graph? Again, don't worry about the side to side right now, just what's at the top? Well, it hits 4 at the top, so -4 to 4. The difference is, of course, that there's actually a solid point here. It's not an open circle like it was there. So we're going to have -4 is less than or equal to y is less than or equal to 4, because those are both solid points. So go bottom to top. So your domain is left to right. So left to right, left to right. And your range is bottom to top. So bottom to top. And that's how you write it. So let's try the next one. Example 4, domain, left to right. So left to right. What's the leftmost x value? And it's like a decimal. I don't know. It's like a third. It kind of looks like it's a third of the way up. Whatever. It doesn't matter because I'm looking at the x value anyway. So, and then the range. So let's do bottom to top. Bottom to top. There's my domain and range on those. Okay, using interval notation for domain and range. This is something that you probably did not do in Algebra 1, so it is a little new to you. Another way to write domain and range is using interval notation. So these are going to look like ordered pairs, but they are not ordered pairs. I know that is a little confusing, but they're not. So just like before when we had our less than and greater than symbols without the equal to, what's going to replace that is these parentheses. And I'll show you in a second what that means. So if you see open circle or you see a line or an arrow rather going to infinity, you're going to use parentheses. If you see a closed circle, solid line, you're going to use brackets. So rewrite each domain from example 1 to 4 using interval notation. So I'm going to pause and just copy down what I put for 1 through 4, and I will be right back. Okay, welcome back from that short break. So I've copied my domains and ranges from 1 through 4 on this paper, so we don't have to flip around all the time to talk about them. So we're just going to write the same domains and ranges, but using interval notation. Here's what it looks like. First of all, anytime you have all real numbers, this is what it looks like in interval notation. So parentheses, negative infinity, comma, positive infinity, closure parentheses. But that's it. So every single time you see all real numbers, and notice this does not specify whether it's x or y. It's just looks like this. Like I said, kind of looks like an ordered pair, except it's not. So I'm just going to go ahead and write that down everywhere I see all real numbers, negative infinity to positive infinity. Okay, so let's try some of the ones that are not all real numbers. So y is greater than or equal to -3. So you always write these in least to greatest form. So what would be the smallest value here? Are we saying that -3 is the smallest value, or are we saying that that's the biggest value? Well, if y is greater than -3 or equal to it, then -3 must be the smallest possibility. So my smallest y value is -3. And since I'm including -3, I've got this right here, then I'm going to use a square bracket. And then so since y can keep growing forever, I can have as big a number as I want for y. It's going to go to infinity, and infinity always gets a parentheses because infinity is not actually a real number. So example 1 and 2 are done. Let's check out example 3. So we're going to go least to greatest. Now when they're written like this, it's a little easier because the number is already there. You just have to decide parentheses or bracket, and that's it. So I have -4 to 4, and again, these are not ordered pairs. You're not going to plot them on the graph. So we are including -4. Including -4. So that means we're going to use a bracket. +4 is not included. Remember, that's where we had that open circle. So that's where that open circle was. And when I'm not including the number in my domain or my range, I want to use parentheses. And this is something we're going to keep doing throughout the year. It's not like you have to master it now. You're just kind of getting some familiarity with it. Start using it. And thank you for watching.